And yeah, you should see it here, guys. We've made like a massive dinner table, and everyone's gathered around it. Wow, if you guys come and join us, it'll get bigger still. Hope you guys are doing well. Let's jump into a very different 2.3. 2.3 is going to have some content I was just mentioning that is not covered in Calculus BC, and such is the case for the remaining part of the course, outside of a few little other friendly review sections that creep in. But, well, look at this. Let's say you've got a differential equation, a linear one at that, and you have some function of x times dy dx plus some function of x times y equals some other function of x. To make things a little bit nicer, we divide both sides by the coefficient of dy dx. And when we do, you're going to have this new friendlier form of a differential equation where dy dx is added to some function of x times y, and then that's going to be set equal to f of x. Now, if f of x is equal to 0, if the right-hand side is equal to 0, we're going to say that we have a homogeneous differential equation. And if the right side is not 0, we would just say it is a non-homogeneous differential equation. Well, that being said, you might think, well, wow, this is brand new. It's, of course, not going to be separable. Maybe that's the big shot. And let's be honest, we've been delaying that for so long. So how do we deal with this issue where we don't have a separable differential equation? The answer is the integrating factor. And a lot of times authors might abbreviate it, a lot of times with parentheses with IF. And if you look at the coefficient of y, which is p of x, whatever is out in front of x, whatever function of x is multiplied to y, in other words, if we were to investigate e to the integral of p of x dx, and if we'd work that out, that would be called an integrating factor. And let's go through the following guidelines. There are really 5 steps that we're going to proceed with. First of all, get your equation in standard form. Standard form is what we see at the top of the page, highlighted in yellow. dy dx plus p of xy equals f of x. Find the integrating factor. In other words, work out e to the integral of p of x dx. Once you know what this is, multiply both sides of your differential equation by that integrating factor. The left side is going to look a lot like the product rule. Always, when we're in this form. Write it that way. And then we'll integrate both sides and solve for y. Well, right now, these might be some just kind of hazy guidelines. You might be thinking, oh my goodness, could we look at a problem together? Here's example 1. Here's my first question for you. Is this homogeneous or non-homogeneous? Homogeneous, of course. We're equal to 0. So is this in standard form, by the way? Yes, it is. Delightfully so. We don't have anything to do. And you could say, well, wow, my p of x is whatever is out in front of y. That's -3. So the integrating factor is going to be, as we just saw, e to the integral of -3 dx. See, if p of x is equal to -3, just plug the negative included into that integral and then work that out. Let's go step by step. What is the integral of -3 dx? What do we get? -3x. Now, of course, at this moment, kids might say, oh, don't forget a constant. Generally here, this is going to sound funny, we do forget the constant momentarily. And that might sound very strange because, calc teachers ingrain that into our minds. When you're finding the integrating factor, though, omit the constant. You're going to see why in just a moment. You're just concerned with finding some function, and of course, you're going to see a lot of exponential types of terms, e to powers. Well, what did it say? Multiply everything, multiply both sides by this integrating factor. What would that look like? E to the negative 3x times dy dx minus 3y times e to the negative 3x equals, well, 0 times e to the negative 3x. See, everything gets multiplied by e to the negative 3x. And I hope right now you realize, yes, the right side is 0. But look at the left side. Envision the product rule. Envision the product rule. In other words, I'm saying, this is the product rule. What was the original product that I took the derivative of? In other words, work it backwards. What do you think? Well, this says take a derivative of y, and yet here's a y itself. What do you think? E to the negative 3x times y. Do you see that? Okay, so wow, all of a sudden you look at this and you think, wow, this is spectacular. All of a sudden I reverse the chain rule. You could reverse the product rule, I'm so sorry. You could double check that if you're ever worried. Say, hey, let's work this out. E to the negative 3x times, well, the derivative of y is dy dx. Plus, put your y in here, take the derivative of e to the negative 3x. So by the chain rule, you're going to get that negative 3 to come out. And hey, there it is. Now, do you think this is helpful? My goodness, yes. My goodness, yes. Here's why. We can now integrate both sides with respect to x. Why with x? Well, that's the way I'm setting up my product rule over here. Tell you what would we get on the left side? I hope you can see it pretty quickly. What do you think? Yeah, e to the negative 3xy. How about on the right side? Just a constant. Just a constant, right? You're saying, oh, I have some function that when I took the derivative of it, I got 0. Well, it's some constant. Maybe it's 0 itself, but it's just a constant. Now what? Well, my goodness, if you're really on your toes, you're going to say, now wait just a second. If I have this, I could say y is equal to c times e to the 3x. Because really that's y divided by e to the 3x. Multiply both sides by it, and we're good to go. Wow. All of a sudden, kids can sometimes look at that and say, wow, would this really work out this way? Would that satisfy the differential equation? It'd be easy to confirm, wouldn't it? And it would just be momentarily taking us a few seconds. For the sake of time on the video, I'm not going to do that. But if you're wondering, it's kind of just like what we did in Chapter 1, saying, hey, would that really work? When I took the derivative of that minus 3 times y, would all of that work out to 0? I hope you can see it. Okay, so let's real quickly take a look at the next problem. All of a sudden, kids are probably going, wait just a minute. Mr. Dobner, that looks way, 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 way familiar. Kids are going to say, it's the same problem. Well, not quite. This one is not homogeneous, is it? We're not setting that equal to 0, this differential equation equal to 0. We're setting it equal to 6. But guess what? It's in standard form. Guess what our integrating factor is? E to the negative 3x. It's the same integrating same integrating factor. Why? Because we're essentially saying the integrating factor is e to the integral of negative 3 dx. Wow. How about that? Multiply everything by e to the negative 3x. And that includes the right-hand side. That includes that over here. Well, now what? Same song and dance, isn't it? We'd say, look, this is a product rule. It's a derivative of two functions multiplied together. I hope you can see real quickly. By the way, do you see how when you've got your dy dx, that's like an incredible hint for what's happening? Right? You could say, well, I've got, e to the negative 3x times y. You bet. Tell you what, let's integrate both sides with respect to x. Look, it's a function of x. Sometimes kids are like, how do you know? Well, look, dy dx, even y is a function of x. The left side, integrate this derivative. We just have e to the negative 3x times y. Help me out on the right side. Ooh, reverse the chain rule. E to the negative 3x, here's your 6, but what are we going to have to divide by? Negative 3. Don't forget a little constant. So here's negative 2 e to the negative 3x plus a constant. You can think of this as e to the 3x down below if you'd like. You could say now I'm going to multiply everything through by e to the 3x, sorry. And I'd have y equals, ooh, what happens when I multiply e to the 3x times e to the negative 3x? I get a 1. That's negative 2. Wow, look at that. There you go. Okay, real quickly, just wrapping this last one up for example 3. As we finish this up, is it in standard form? No. Ah, doggone it. What do we have to do? Divide everything by x. And we'll have dy dx is equal to negative 4 over x y. Over here we have x to the 5th, e to the x. Our integrating factor is going to be e to the integral of negative 4 over x dx. Okay? And if you want a little bit of help with that, first of all, friendly reminder, you can pull that negative 4 out. And what is the integral of 1 over x, of course? We just have what? Natural log of the absolute value of x, right? And then, tell you what, I can bring that up as a power. And here's the real cool thing. If you really think about it, will you need absolute values anymore? No way. Fourth powers are going to guarantee everything is non-negative. So you can raise that up. It's x to the negative 4th, but that's 1 over x to the 4th. Guaranteed non-negative. You don't need the absolute value around it. What is e to the natural log of 1 over x to the 4th? That just becomes 1 over x to the 4th. Wow. That's your integrating factor. That's what we're going to multiply to everything. 1 over x to the 4th. So let's do that real quickly. I'm going to say 1 over x to the 4th times dy dx. Here's minus 4 over x times 1 over x to the 4th y. And here's 1 over x to the 4th times x to the 5th e to the x. And real quickly, we've got 1 over x to the 4th dy dx. This thing becomes negative 4 over x to the 5th. And on this side, we just have x e to the x. Let me ask you this. Do you see a product on this left-hand side? What do you think we're really taking the derivative of? Y times 1 over x to the 4th. Right? Again, look at that first term. Huge, huge, huge help. And my goodness, at this point, tell you what, let's integrate both sides with respect to x. And the left-hand side, continuing over here, we have y times 1 over x to the 4th. Ooh, x e to the x. How about a little tic-tac-toe from integration by parts? Derivative of x is 1 and then 0. Here's e to the x. Here's e to the x. Help me out. What is that exactly? This antiderivative is x e to the x minus e to the x plus a constant. One more thing, multiply by x to the fourth.